Okay, so I hope you're able to calculate those out. I did. I paused the video and I'm back now. So I wanted just to take my time calculating and make sure I didn't make any mistakes. So like for instance, purple and smooth, 69 minus 64 is 5, squared is 25, divided by 64 is 0.4. And add that to the next one, which is 22 minus 21 is 1, squared is 1, divided by 21 is 0.05. 16 minus 21 is 5, squared is 25, divided by 21 is 1.2. And this one's 0, 7 minus 7 is 0. Okay, so when you add all those up, we get a chi-squared value of 1.65. So now that number, we're going to look at a chart, and we're going to use that number to determine whether or not this is being followed, whether or not the expected and the observed are close enough to each other that we can be pretty confident that the Punnett square is true, that the traits are dictated by only 2 genes with only 2 alleles in each gene, and that purple is dominant to yellow, and that smooth is dominant to wrinkled, which is our null hypothesis. Okay, if that number tells us that we're too far off, then we have to come up with an alternative hypothesis, which would be like, maybe there's 3 genes involved. Maybe purple's not completely dominant to smooth, and so on. All right. So I just took a screenshot of the chi-square section from our formula sheet. All right, we already used the formula. So now we have to read the table. So we have to kind of figure out which column and row to use. Okay, the row wasn't determined for you. If the question asks for you to determine to a 95% confidence, we're going to use that value. If the question asks you to determine to a 99% confidence, we would use that row. So we'll just use the most common one, which is the 95% confidence. In science, typically accepted values are stating that the statistics brought us to a 95% confidence that what we're telling you is true. Okay, or whatever, however you want to say that. So the degrees of freedom, we have to figure out which column. It says here degrees of freedom are equal to the number of distinct possible outcomes minus 1. So we have to know what the distinct possible outcomes were. If you're flipping a coin, there's either heads or tails. So if you're flipping a coin, it'd be 2 minus 1 equals 1. Well, we're not flipping a coin. We're looking at an ear of corn where there were 4 distinct kernel possibilities. Right? They're either purple and smooth, purple wrinkled, yellow and smooth, or yellow and wrinkled. So our distinct possible outcomes, and we calculated this, like we did it 4 times, right? 1, 2, 3, 4. There were 4 calculations that we had to sum up. So distinct possible outcomes is 4 minus 1 equals 3. So we are going to use that column and the 0.05 row, and we're going to use that number, and we're going to compare our 1.65 to 7.81. Well, since our number is less than that, there's not much deviation, right? There's not much going on different. Right, like 0, a chi-square of 0 would be exactly what we expect here. So the way I would write this is that because 1.65 is less than 7.81, we fail to reject the null hypothesis. That's just a fancy way of saying that we accept the null hypothesis. Usually they say fail to reject the null hypothesis, but since the number was very small, the statistics are telling us that we can pretty much say that this is what's going on here. We had pretty close values, right? We had we expected 64, we got 69. We expected 21, we got 22, right? So pretty darn close. And that number is telling us. So if this number, if our chi-square value were like 10, 10 is greater than 7.81, meaning there's just too much difference and something's going on here. There's some other thing at play, and we would have to come up with an alternative hypothesis. But the observed is pretty close to what we'd expect. Okay. And then these are just a couple challenge problems, optional, but I have a couple other ears of corn with different genetics. So this is, I'm just going to tell you right now, this is not a 9-3-3-1 ratio. Okay, this is something else going on here. So see if you can figure out what the ratio is for that one. It's not a 9-3-3-1. If you want to go even further, you could try to figure out what the corn plant parent genotypes would be that would have to produce an ear of corn like that. And then I've got another one here as well. So again, not a 9-3-3-1. This was not the result of a dihybrid cross. Again, on this one, you can see it's interesting. There are no wrinkled. They're all smooth kernels. Here, there's wrinkled, but seems to be a lot more yellow than the one that we had worked with. Anyway, hope this was helpful. I know these are all some longer videos, but the chi-square concept is can be tricky to a lot of students. I would really recommend walking through this one on your own. I'm going to give you some review problems in a week that have some more chi-square examples on them, so you can practice at a few more of these. You can also, if you want to look up chi-square, Bozeman's got a great video on chi-square analysis, and there's other videos you can watch as well.